Okay, the first big property we learn when we start the process of solving linear equations, and these are linear equations in just a single variable, is we learn the addition property of equality. And what the addition property of equality allows us to do is it allows us to add or subtract things from both sides of the equation. So fact, when given an equation, the equal sign indicates that the equation is balanced, meaning the left side equals the right side. As we go through the solving process, we have to maintain this balance. So this is our goal. We must maintain balance in the equation while solving. And remember, to solve, we undo what has happened to the variable. So as we start isolating the variable and undoing what's happened to it, we have to always keep balance in mind. And this property is one of those properties that allows us to do this. So the addition property of equality, it says this property allows us to move terms from one side of the equation to the other by performing the same addition or subtraction to both sides of the equation. So if I add something on the left, I have to add something on the right because that helps me maintain balance. If I subtract something from the left, I have to subtract that same something from the right in order to maintain balance, okay? So symbolically, it says, let's pretend A, B, and C are real numbers. They can be fractions, decimals, integers, whatever. They're real numbers. If I know that A equals B, then A plus C is going to equal B plus C. I add the same thing to both sides, it's still going to be equal. Similarly, if A equals B, A minus C is going to be exactly the same thing as B minus C. So this allows us, again, to start isolating the variable by adding or subtracting, but I have to do it on both sides of the equation. Okay, so let's see this in practice. All right, so example 3 says, apply the addition property of equality to solve each equation. Check the solution. We have simple one-step equations here, nothing crazy. Our goal is to isolate the variable. I tend to always use X when I make worksheets, but just know that the variable could be really any letter of the alphabet. We could have X's, Y's, Z's, N's, P's, whatever. But again, I tend to just use X's. So for part A, I have X plus 5 equals 9. My goal is to isolate the X while maintaining balance. The issue is that 5 has been added to X. Well, how do I undo addition of 5? We have these things called inverse operations, and they're operations that undo each other. So inverse operations, these are operations that undo each other. Well, for us, addition and subtraction are inverse operations. They undo each other. And multiplication and division are inverse operations. They also undo each other. So if I want to undo addition, I subtract. So I want to subtract 5. But if I subtract 5 on the left, I have to also subtract 5 on the right. So if I look at this, I have x plus 5 minus 5. Well, what is positive 5 minus 5? It's just 0. So one thing you'll notice a lot of the times is mathematicians, we get really lazy here. We're like, oh, the 5s cancel. They do cancel, but they secretly cancel because 5 minus 5 is 0. X plus 0 is just x. Okay? But then on the right-hand side, I have 9 minus 5, which is 4. So at this point in time, I think the solution is going to be x equals 4. This is going to be the value that satisfies the equation. This is the value that's going to make this equation true, but I want to just double check it. So we already learned how to check if a value is the solution. So I want to check to see if x equals 4 satisfies the equation. So I'm going to rewrite the equation. Anywhere I see an x, I'm going to put a 4. So I want 4 for x plus 5 equals 9. Well, what's 4 plus 5? It is 9. Does 9 equal 9? Absolutely. So we can say without a shadow of a doubt, the solution to this equation is 4. And we use this thing called set notation. It just stands for, hey, this is my solution set, okay? And we'll write the solution inside curly braces, okay? You don't put the x equals, you would just say x equals, and then the solution set is 4. So it's really common to see that notation. I don't get like super bent out of shape if you forget your curly braces. I'll forgive it if I specifically ask you to write it in set notation. You need to remember your curly braces, but just don't be alarmed if you see that notation. Okay, let's look at part B. So in this case, we have x minus 11 equals negative 17. So our goal again is to isolate the x. How do I get my x alone? Well, I have to look to see what has been done to x. X has been subtracted by 11. Well, I want to undo that subtraction. And remember, we need to figure out the inverse operation. Well, I know that if I want to undo addition, I subtract. That's what we did in the previous example. So in this example, to undo subtraction, I want to add. So I'm going to add 11 to both sides of the equation. Now, I do this vertically. Some books and some videos you may watch, they'll show you this horizontally. That's fine. It works the same way. Essentially, what we have is x minus 11 plus 11. That's going to be the left. Well, negative 11 plus 11 is just 0. And then x minus 0 is just x. So we got our x alone. But because I added 11 on the left, I had to add 11 on the right. So let's simplify the right-hand side. So I have negative 17 plus 11. When you're adding two numbers with different signs, remember you secretly subtract. So 17 minus 11 is 6. But did I have more negative or did I have more positive? 17 is bigger, it's negative. I had more negative. So my answer here is going to be negative 6. But let's check it, okay? I'm going to rewrite my equation. Anywhere I see an x, I'm going to replace it with a negative 6. So I get negative 6 minus 11 equals negative 17. Hopefully you've had a chance to really practice the adding and subtracting of integers, but just in case, you can always convert subtraction to addition. To do that, instead of subtracting positive 11, we're going to take negative 6 and we're going to add negative 11. Those are the same thing. And then you're adding two numbers with the same sign, so you add the absolute values. 6 and 11 are 17. Because both numbers were negative to start, the result is also going to be negative. So I get negative 17 equals negative 17, which is true. So I could then say x equals negative 6. And again, that's that fancy set notation, okay? Let's try two more. We're going to try one with a decimal and one with a fraction. For part C, I have x plus 3.5 equals negative 2.8. I want to get my x alone. What has happened to x? Well, 3.5 has been added to x. How do I undo addition? Well, I subtract. But if I subtract on the left, I have to also subtract on the right. So going back to the left, I have x plus 3.5 minus 3.5. Well, 3.5 minus 3.5 is really just 0. So again, we'll get really lazy and we'll be like, oh, the 3.5 is canceled. Just remember, it cancels because it equals 0. X plus 0 is just x. And then over here to the side, you may have to do a little extra work. So we have negative 2.8 minus 3.5. Okay? Get in the habit of really understanding what you're doing so you don't have to do this side work every single time because this is going to slow you down drastically. And like right now, it's not a big deal, but later in this course, being slowed down by these simple operations is going to be problematic. All right, so I could rewrite this as addition. To do that, instead of subtracting positive 3.5, I want to add negative 3.5. So I'm really just adding two numbers that have the same sign. So I want to take 2.8 plus 3.5. 8 and 5 is 13. Carry a 1, drop down your decimal. 3 plus 2 plus 1 is 6. So we really get 6.3, but it's going to be negative. So at this point, we think x is negative 6.3. But let's check it. Okay? Anywhere I see an x, I'm going to plug in negative 6.3. I want to check my work here. Now, I've got negative 6.3 plus 3.5. I'm adding two numbers that have different signs. So I really want to subtract. So I'm going to do a little subtraction off to the side. All right, you can certainly use your calculator for some of this, but I do want you to understand, like, especially when you have integer values, like the fractions and the decimals, it's much more common to use your calculator. But when you have just integer values, you really need to understand how these processes work, okay? So don't just always jump to the calculator, okay? Now, we had negative 6.3 plus 3.5. We're adding two numbers with different signs. We subtract their absolute values, so that's going to be 6.3 minus 3.5. I cannot take 5 from 3, so I borrow. 6 becomes 5, 3 becomes 13. 13 minus 5 is 8. Drop down your decimal. 5 minus 3 is 2. And then we have to determine positive or negative here. Well, I have 6.3 negatives. I only have 3.5 positives, so that means this 2.8 is going to be negative. Does negative 2.8 equal negative 2.8? Absolutely. So we would say that x equals negative 6.3, and we wrote it like real fancy. Okay, that's like the fancy formal way to write your answer in math. Okay, so last up for this part, we have x minus 3/4 equals 2/5. So I want to get my x by itself. That's the whole goal. Isolate your x. What has happened to x? Well, we subtracted 3/4 from it. How do I undo subtraction? I use addition. So I want to add 3/4 to both sides here. Well, on the left, I have x minus 3/4 plus 3/4. So negative 3/4 plus 3/4, that's just 0. We say they cancel. X minus 0 is just x. But I need to do a little bit of side work for my 2/5 plus my 3/4. Okay. So again, I want to remind you how to do some of this stuff by hand, because it does like mess up the flow every time you stop and go back to your calculator. Though I do allow calculators. I just want you to remember some of this stuff by hand. 5 and 4 are not common denominators, but the smallest number they both divide into is 20. So then we ask ourselves, what do we multiply 5 and 4 by to get 20? Well, to get 20 for the first denominator, I would multiply 5 by 4. So I want to multiply the numerator and denominator by 4. To get 3/4 into something over 20, I would multiply the 4 by 5. And if I multiply the bottom, I have to also multiply the top. So what we end up with is 8/20 plus 15/20, which is going to be what, 23/20? So at the moment, we think the final answer is 23/20, but we want to check. Okay, so we're going to check x equals 23/20. So I'm going to rewrite the equation. Anywhere I see an x, I'm going to plug in 23/20. So I've got 23/20 minus 3/4 equals 2/5. Well, we know that 3/4 is 15/20. So we have 23/20 minus 15/20. We know that 2/5 is really equal to 8/20. So we've already got the common denominator stuff worked out here. So I can take 23/20 and subtract 15/20. I just subtract the numerators. So 23 minus 15 is 8/20. Does 8/20 equal 8/20? Absolutely. So we can say here that the solution really is 23/20. I will say a couple of things. Typically, if you start with fractions in your equation, your final answer is going to be a fraction. There is not really ever going to be a need to write this as a mixed number. It is rare when you're solving equations in algebra to use mixed numbers. You almost always use the improper fraction. Occasionally, you'll use the decimal, okay? But leave this improper. There's no reason to do anything with 23/20. The only time you'd really do something with this is if the 23 and the 20 could reduce. 23 and 20 don't reduce, so that would be your final answer, okay? All right, and that's it for this particular topic. So make sure you understand how to use the addition property of equality with integers, decimals, fractions. They could all show up.